Today, I'm going to give you a brief outline of kinematics. In fact, there are various misconceptions in the most fundamentals. So let me first of all give a clarity of all those points. In fact, I'll give you an example. There's often a confusion between distance and displacement. When can you get the distance? How can you get the distance? And when should you get the distance? How to get the displacement, etc. I'm going to give you in the course of my lecture an absolute clarity of these points so that you will never ever get a doubt at any point of time in your life. Let us now start with kinematics. Very simple. What is kinematics? In fact, it is nothing but the study of motion without any reference to the cause of motion. In fact, how this particle is moving, how that body is moving, etc., we are not concerned with. We are not even concerned with what kind of forces that are acting, etc. What we are concerned about is its movement. It means what? It could be that of a particle or any body or any image. Be careful about the points that I am talking about here. Be careful about this image, or for that matter, even a shadow. A shadow can move this way, that way. A shadow can oscillate. A shadow can move linearly, move non-linearly, move curvilinearly, move in a circular path, anything. But we never talk about the cause of such motion. We are only concerned with that. Therefore, what do you mean by a particle? Particle, we treat it as a point mass. In fact, point masses do not exist in nature. You are aware of it. Otherwise, you should know about that. Point mass is a concept where the particle doesn't have a shape or size. That is the meaning. If you talk of a body, it has certain shape and certain size. Therefore, when I use in kinematics a body, I am talking about a concept called center of mass, which we will be dealing with at a much, much later stage. So hereafter, whenever I talk of kinematics, it could be either a shadow, it could be that of an image, it could be that of a body, it could be that of a particle. I hope this point is clear to you. Now, if that is the case, what is it that we are going to study in kinematics? In fact, motion, when I talk of, this motion is characterized by one, position, two, displacement. I'll come to each one of these things separately and discuss in great detail. What I would expect you to do is get an absolute clarity on these concepts, and that will give you a great impetus for you to study further. Then I can talk of velocity, I can talk of speed, I can talk of acceleration. For the time being, these are enough for us. Now, if you look at each of these six parameters that I am talking about, essentially, you look at position, displacement, distance. These things I can talk for a shadow. These things I can talk for an image. And these things I can talk for, as I said, any particle or point mass or any body. Whenever I refer to body in kinematics, I refer only to point masses or points only. So we are not going to get into any complications as far as the shape is concerned, the size is concerned, etc. So let us now look at each of these things one by one. What do you mean by position? See, after all, whenever you have a particular point, I want to say that this is the point. Where is this point? How do you say that this is the point? So obviously you need to have some origin, some coordinate system, maybe x, y, z. So you say from this origin, its coordinates are 2, 3, 5. That's fine. 2, 3, 5 is the position of that. But then this position you may indicate it with respect. In respect of this, you may probably indicate this with a coordinate, as I have already spoken about, or in terms of a vector. So, if I have a vector, I generally take by convention x direction. The unit vector is I, y it is j, and z it is k. So if I have say any point, I call it as 2, 3, 4, then probably I can write this position vector as 2y plus 3j plus 4k. Now this is a vectorial representation of a position, or simply called position vector. As I said, this position is that of a particle or a point. As I already mentioned, I need not have to talk about this every time. But I want you to understand kinematics is not exclusively defined for these particles or bodies. This has to be kept in mind all the time that you work on these things. So the first thing is this position of the particle we have stated. That is fine. Now if particle, for example, changes from a position this to another position, say 3, 4, 6, for example, if that is the case, what is the change in the position? Or what is the vectorial change in position? The vectorial change in position means, first of all, I write what is the position of the same particle, but in a given interval of time, this has moved from, say, point A to point B. So I need to know, I want to know, what is the change in position? Change in position means final position minus initial position. If I do that, you are aware of vectorial subtraction. So it is 3i minus 2i plus 4j minus 3j plus 6k minus 4k 2k. This is what we call as change in position delta in that interval of time. And this is what we call as displacement vector. And I want you to understand that displacement is a vector quantity. Vector quantity. This is how displacement is defined. In fact, I just tried to tell you all this mathematically, but if I go theoretically, what do you mean by displacement? To put it very simply, displacement is nothing but vectorial. Most of the definitions that I am giving are practical definitions. For example, when I talk of vector, you will never come across this kind of a definition in any of the textbooks that you come across. But whenever I give this definition, I am actually giving you whole lot of information in this definition itself. The vectorial change in position of say a particle. As I told you, it's not necessary that it should be only a particle, it could be for anything. What is that anything? Particle, body, shadow, or image. The vectorial change in position of a particle in a given interval of time. This is called the so-called practical definition of displacement. And this is always equal to final position minus initial position. Many times I use this subscript. For final, I for initial, don't get confused with this I and the I that I have used as the unit vector. There is a hell of a difference between these two. So therefore, this is now when you go theoretically, let me now explain vectorial change of position, all that is fine. Now here initially the particle is at this point. Now the particle may be moving like this and may land up there. Let this point be P. There are infinite ways for the particle to reach from A to B. Which way we do not know. We need not know. We may know it. We need not know. As far as displacement is concerned. For example, when this particle is here initially and the particle is here finally, I join these two by a straight line and put an arrow there. So AB is my displacement in this interval of time. If I talk of another interval where the point is C, then I would draw a vector like this, AC, that is the displacement in this interval of time. So one has to distinguish what kind of interval are you taking. Accordingly, your displacement will change. Now, let me presume that point B, A to B might have gone like this, or it might have gone like this, or it might have gone like this, or in any zigzag fashion. It makes no difference to you as far as displacement is concerned. Now, this is a very, very important point. Do not get carried away with the bookish definitions. And this is going to give you a much better insight into the concept of displacement. So what do you mean by this displacement here? One thing which we can interpret is that it is independent of the path. No matter how this particle reaches from A to B. As I have given you several possible ways, this could be there. As I said, there are virtually infinite number of ways by which the particle could reach from A to B. So, if that is the case, it is independent of the path followed by that particle. That is number one. Second thing, and if I want to know what is the magnitude of displacement, so this is magnitude of displacement. In this case, it is the magnitude of vector AB. Magnitude of AB. So that means from here till here, this is nothing but the shortest possible distance. Mind you, never try to give the definition of displacement as the shortest possible distance. That is not correct. That is one of the characteristic features of this displacement, but not definition. So, number one, it is independent of the path. Number two, this is the magnitude is the shortest distance between the 2 points, initial position and the final position. Now, incidentally, if you look at, say, point A particle might go like this, and suppose it reaches point A in that interval of time. Then if I ask you what is the displacement here, the displacement is 0, or we call it as a null vector or 0 vector. I am sure you are aware of the vectors. Presuming that you are aware of the vectors, I am going ahead with this kind of definitions. So the displacement of a body in motion could be 0 in a given interval of time. Now that's very important. I am emphasizing on this point for a particular reason that you will understand it later on, not at this point in time, right? So we have now looked at various characteristic features of displacement. Now if I ask you, when can the displacement be 0 for a body in motion? Then your answer must be, it should be in a closed path. It should be in a closed path. That is very important for us. Okay? As I said, I'm just talking about the theoretical part of displacement. We already saw the position, we already saw the displacement. Now let me come to another very important aspect of this kinematics, that is distance. So this is where most of the people often get confused. Where to use distance, where to use displacement, or both are one and the same. What is this confusion? Let us now try to look at this. The same example that I took before, I am now considering 2 points A, B, and as I said, suppose the particle has gone like this. This is the thing. As far as the displacement is concerned, it is fairly simple. You need to know the initial position, you need to know the final position, and simply draw a line from A to B. You say that that is the displacement vector. There the matter ends. Sometimes in this motion, displacement is important. Sometimes distance is important. Now what is distance? Distance means from this point to this point, what is the total length of the path covered by this particle in this interval of time? What is the total length of the path covered by this particle in the same interval of time? That is what we call as distance. Now, distance is a scalar quantity. You have to be very, very clear about this. Distance generally no standard symbol is used, but still for convenience we may use D for distance here. So D is a scalar, whereas displacement obviously S bar is bound to be a vector. Therefore this is a vector quantity and this is a scalar quantity. So distance, now you look at this. Total length of the path. Now this could be like this could be like this, or it could be like this also. That means what? Distance is almost always more than the magnitude of the displacement. Never give a statement that distance is more than displacement. That's not correct. Because you can't compare a scalar with a vector. And if I take the magnitude of the displacement, then I can compare distance with the magnitude of the displacement. Then I can say, you look at this, you will know for yourself, distance is always more than this length. And this is the shortest possible length, you know very well. So distance can at the most be this or more than this. So I probably can write distance for the same interval of time. Be careful about that. Is always greater than or equal to magnitude of the displacement. I am giving you suffix delta t that indicates for the same interval of time. This is how we compare. Now let us see, when is displacement imparted and when is distance imparted. For example, if a person is started from his house, is going for a walk, and he makes about say 4 or 5 turns around the park. And what is his displacement if he comes back to his original position? What is the distance? Then you look at all the number of rounds that he has undergone, count it, and maybe suppose if one round corresponds to 1 kilometer, then if he has undergone 4 such distances, 4 such rounds, then that amounts to 4 kilometers distance he has covered. But his displacement is 0. Now he has gone out for walking. Now would he say, how much I walked today? I said my displacement is 0, I have not walked anything. Ridiculous. We know very well. So in this case, distance is more important. Sometimes the particle is moving, its position is important for you no matter how it goes. In fact, when you try to get any displacement through any analytical technique, they will give some equations and they'll ask you to get the displacement. You do analytically, you will get only displacement, but you will never ever get distance direct. Be careful about this. In fact, distance doesn't have a formula. Distance has always got to be interpreted. It doesn't have a formula. I am repeating this. You must understand this. I hope this point is clear to you. Now, this is very crucial. Very crucial. Now, that is fine. So, we have seen position, we have seen displacement, and we have seen distance concept. I hope by now the distinction between distance and displacement is clear to you. Now the next parameter that I spoke about was velocity. Another colloquial term, many people use it. Now to put it in simple form, your velocity is a vector quantity. It is nothing but rate of change of position. The rate of change of position is your velocity. And obviously the magnitude is in meter per second SI unit. Direction will have to be specified. We'll talk about that at a later stage. Now, if I write this as in a given interval of time, if the particle goes from one point to the other, I will write it as delta R by delta t. From one point to the other point. This is what we call as average velocity. What do you mean by why am I introducing suddenly average velocity here? If this is average velocity, delta by delta t is your average velocity. In other words, total displacement by the time interval. This is what we call as average velocity. Average is a very dangerous term. Be careful about that. In fact, the word mean, M-E-A-N, mean, doesn't have any meaning at all. I'll give you a simple example of 2 people scoring 100 marks out of 100 and another fellow scoring 0. The average is 50, which neither of them got it. But does it mean that we should never use averages? There are the great utilities of averages, but our interpretation must be perfect. Then all these definitions are not useless. Otherwise, remember, if this is average, this is what we call as instantaneous velocity. What do you mean by instantaneous velocity? The velocity at a particular instant of time. That is called instantaneous velocity. Whenever you use derivatives, you will get only instantaneous velocity. Whenever you use this formula, you will get only average velocity. Now, since this is displacement related, if you put your displacement is 0, your average velocity is also 0. Would you say that the body has not moved at all? No. The particle did move. The particle has undergone so many circles if it is a circular motion. And then at the end of it, if the particle reaches the original position, we say the average velocity is 0. Because the displacement is 0. But you can never say instantaneous velocity is 0. I'll talk about this instantaneous and average at a little later stage. But initially I want you to understand that the definition of velocity is related to the position or it is related to displacement. So this is as far as velocity definition is concerned. Now I will give you an example here. Suppose your R is given as 3t square plus 4t plus 5. R is a function of time, it is given. Now I want to know what is the velocity at a time. What is the velocity of this particle? Say at t is equal to 2. At t is equal to 2, what is the magnitude of velocity? What do I do? Go by definition. Your velocity is given as, the position is given as a function of time. Therefore, try to get the derivative of this. It's fairly simple. I'm writing it as 3t square derivative 60 and 4t derivative 4, 5 constant derivative 0. Therefore, velocity is given as 6t plus 4. That means, if I want to know what is velocity at t is equal to 2, then what do I do? 6 into 2 plus 4. So 16 units is the velocity at t is equal to 2. For example, if I ask you, what is the average velocity during the first 2 seconds? Remember, when you want to answer the questions, half of the answer lies in the question itself. Understand the question thoroughly well. Whenever the word during is used, you have to go for average. Or when average is given during interval. Whenever you want to get the instantaneous value, they will always say at a particular time. Please be careful about this. Now, if I talk of during the first 2 seconds, what do you mean by that? I want to get average velocity. I told you it is R2 minus R0 by 2 minus 0. What do you mean by this suffix 2 here? R2 means position at t is equal to 2. R0, position at t is equal to 0. And final position minus initial position will directly give you the displacement, as we already saw in the previous definition exercise. So what is R2 minus R0? So I substitute t is equal to 2 here. T square 4 into 3, 12 plus 8, 20 plus 5, 25 minus t0 means you will get only 5. So divided by 2. What is that answer? 10. First 2 seconds average velocity is 10 units. After 2 seconds the velocity is 16 seconds. Do you understand the difference between the hell of a difference between these 2 cases? When I am going to wind up the lecture, I will definitely recapitulate all these points to you in a nutshell so that you won't have any issues while following these concepts. Right? Now, if this is your velocity definition, go to the next concept speed. Now, it is the rate at which a particle covers the distance. The rate of distance covered, speed, and rate of distance. And the distance itself is a scalar. Therefore, this is also bound to be a scalar. Of course, units are same as the magnitude of velocity. So, speed, scalar, number one. Number two, speed relates to the distance, not displacement. Velocity is related to the displacement or position. Okay? In fact, if I subtract final position and initial position, I am not going to get the distance at all unless the particle is moving in unidirectional way. Unidirectional means same direction without changing if it goes. Then for me, distance is same as magnitude of displacement. So there is no difference between these two in such a case. So it is rate at which distance is covered, that is your speed. In the same way as I said, total distance, if I take by total time, then what do I get? Average speed. If I take total distance by total time, I will get average speed. You recall in velocity what did we do? Total displacement by total time, that is average velocity, and total distance by total time is called average speed. Now, coming to the next point, average speed is over, then what is your instantaneous speed? The instantaneous speed is nothing but the magnitude of the instantaneous velocity. Remember, I am not equating the instantaneous speed directly to instantaneous velocity. Remember, I repeat this point, I already made this point a little while ago, that you can never ever compare or rather equate speed with velocity because two are two distinctly different physical quantities. There's a hell of a difference between these two. So, speed is used in certain instances, velocity is used in certain other instances. You should remember that. I hope you have now got this point as well. So, we discussed so far the position, displacement, distance, velocity, speed. In velocity and speed, instantaneous velocity, instantaneous speed, average velocity, average speed. Now, finally, I talk of this called acceleration. Now, by definition, it is rate of change of velocity. The rate of change of velocity is acceleration. As we defined previously, if I want instantaneous acceleration, then I'll take the derivative of the velocity. But if I want average acceleration, then I go by change in velocity by change in time. Now, these are all the actual, sometimes theoretical, sometimes mathematical definitions and concepts of those characteristic features of the motion. There are various other features. I am not looking at all those features in kinematics. So, what is it that we have learned in this lecture so far? We first of all said motion is not necessarily for a particle, not necessarily for a body. It could be even for an image or a shadow. The first important point you should always remember. This is going to be useful to you at a later stage. You will understand it. Okay? Number one. Number two, we said the motion is characterized by about 6 parameters that I have tried to give. Number one, position. 2, displacement. 3, distance. 4, velocity. 5, speed. 6, acceleration. And in all these things, the most important aspect is the distinction between the speed and, distance and displacement. Distance and displacement. So, the distance is a scalar quantity, number one. Displacement is a vector quantity. Never equate these two. As I said, one is a scalar, another is a vector. Two distinctly different physical quantities. So, any analytical expression when you are trying to work out, you will get only displacement. In fact, the distance you can never get directly. There are ways to interpret the distance. I will discuss that in 1D motion. Then we will discuss the other aspects of it at that stage. And then we went on to define instantaneous and average, both for velocity as well as for speed. Speed pertains to the distance, velocity pertains to position and displacement. And finally, we looked at what is acceleration. In this acceleration also, we looked at instantaneous acceleration and average acceleration. Now, another important concept that you must have come across in this lecture is one, instantaneous, two, average. This is a very, very important concept in physics. You cannot ignore this. Every time you look at, am I looking at instantaneous value or am I looking at average value? That's how you have to look at it. Now, what do you mean by instantaneous? Although I said before, as I said, I'll recapitulate it again. Instantaneous stands at a time, at a point. No interval, no space interval, no time interval is given. But average is during an interval of time. For example, a scooter has started from point A. In a straight line, it is going to point B. He started, naturally he starts with zero velocity. He accelerates the vehicle and it goes. For example, if somebody asks you, what is velocity? With the knowledge that we gained, maybe in 8th standard or 9th standard, what is it that we were taught at that point of time? You were taught, look at this final position, look at the initial position. Subtract, divide with the time interval. So, if a person starts at 8 o'clock, he reaches the destination at 9 o'clock. I want to know what is the average velocity between 8:30 to 8:40. So, what is the duration of that time? 10 minutes. In this 10 minutes, what do you do? At 8:40, what is the position you see? At 8:30, what is the position you see? Subtract, divide with 10 minutes. Convert into seconds, you will get so many meters per second or whatever. If somebody may ask, no, I want to know between 8:30 to 8:31, so only 1 minute interval. Fine. There are people who would still come to a lesser time interval, 8:30 and 1 second later. Somebody out of curiosity said, no, between 8:30 and 0.1 second later. Somebody will say 0.00001 second later. And one fellow comes and says, tell me what is the velocity at 8:30. With the knowledge that we have from 9th standard, what is it that we generally do? We directly take number one, at that time displacement is 0. At that time interval is 0. So answer is 0 is 0. 0 is 0 can be anything. I am talking of colloquially. That was very difficult for you to. That doesn't mean you can say the velocity is 0. Average velocity 0. That is absolutely wrong. The vehicle is after all in motion. So it should have certain value. Only problem is we are not aware of the technique to evaluate that value. That doesn't mean it doesn't have a value. Alright? Now that is where your derivative is going to help you. In fact, if time permits at a later stage, I will definitely explain this graphically and then analytically, both. Alright? So thank you for this part of it, and we will continue from here onwards in my next lecture. Thank you.